not a problem.
Thank you. Okay. Richard e Saurabh adesso ci mostreranno alcune live demo interessanti. Prego.
Thank you. So in this section of our presentation, we will be demonstrating some use cases in defense and also relating to the trends which we have seen and how hexagon technology can help you build and meet your custom geospatial requirement in a high performance hybrid 2D and 3D view. So, slide order. So as Vincent also mentioned in his presentation, the use of native 3D apps for dismounted soldiers, for terrain scouting personals, or for our soldiers in the field is becoming more popular nowadays. There were 2D applications available. There are some 3D applications which you can make by making a hybrid web-based application and packaging it into an Android. But if you look from Google itself, who has this Android API for native 3D applications, there is no clear roadmap on integrating full 3D capabilities in an Android application. And our customers in defense domain, they were looking for a high performance hybrid 3D app which can run on Android tablet and which can be used by the soldiers. So our product team, the Luciad product team, came up with a brilliant idea. And one of our youngest products, Luciad C-Pillar, which offers an API to build custom geospatial applications in C++ and C# language, can also be used as a Java binding to develop native Android apps with full desktop level 3D capabilities. So on the right hand side in this video, you'll see very high resolution satellite imagery and terrain data with some 3D buildings, some defense symbologies being loaded in a mobile application, in a native Android application, and along with the entire, let's say, your command control or your information system, C4ISR system, which is running on a desktop, is running with the same performance in a mobile 3D application, but it can also leverage the sensors or the physical hardware available on your Android device, or maybe a ruggedized tab, maybe it's a GPS location, it's a camera, and soldiers can use this application. Suppose one of the person using the application spots a sniper or some disturbance in an area, instantly it can be communicated to all other soldiers, and once the network connection is there, it can also be communicated to the headquarters as well. So, this Luciad C-Pillar already exists from past couple of years, but it is only available for C++ and C# based desktop applications for now. But very soon we will have our release of the first version for Android, which is Luciad C-Pillar 2022.1, and this will be released in mid of January coming year 2023, and then developers will be able to build native Android apps with all desktop capabilities for handheld application. Arjun, will you play this video, please? So similar video which you saw in the previous slide, but with a lot of vector data sets combined with multiple type of geospatial data, all the support for hand gestures, pinch, tilt, rotate in 3D in a native Android application. And on the second video, you will see an example of indoor navigation. So you can also load your CAD BIM models, or you can load entire 3D data sets and do a first-person navigation in your Android application. And after the presentation, when you are coming for the demo sessions with HoloLens and Oculus Quest, you can try the application on a mobile device, or if someone wants to try, so full 3D capabilities in a tablet or in a mobile in Android running on the mobile device itself. Now, as Luciad C-Pillar is a relatively new product, so still most of you know the Luciad portfolio, Luciad Fusion, Luciad Lightspeed. It has all the defense and aviation and maritime specific standard support. And similarly, the C-Pillar is also growing day by day. And here in the screenshot, you see some of the APIs, some of the functionalities that will be a part of the next release or in the coming future. And all this, because it's a one product, will be also available for your dismounted soldier or Android-based application with Lucia C-Pillar. Another small example, in the white device, Oculus, when you were watching the demo, you were seeing this kind of visualization where you can expand your entire native application, Android application, a big data wall, and all the group of soldiers, or while during a briefing, during some exercises, you can have a big view, interact with just your hand gestures, pinches, zoom, click, create objects, and do a mission simulation, mission preparation or training and exercise. All this just with one product, Lucia C-Pillar. Some maritime use cases. So some of you might know that the Lucia portfolio incorporates support for all maritime domain related activities, from visualizing millions of static plots of vessels and ships, or from visualizing dynamic data coming from automatic identification system, moving tracks, and the support for not 1,000, 10,000, but millions of moving points without any lag or without any performance degradation in your, let's say, combat management, naval ops, or coastal surveillance system. Along with the AIS plots, there is support for nautical charts, S57, the unencrypted, and S63, the encrypted nautical charts, and Hexagon being closely working with IHO, International Hydrographic Organization. We also have S100 and S101 formats to be released very soon, and it's already on the Lucia roadmap to integrate those formats as soon as the data sets become available as well. So here in the video you see the static plots analysis, hovering over a vessel you can see the MMSI number, speed, course as per your requirement, do some heat map analytics, filter the data based on all the parameters or the attributes that are available within the data. You get very flexible and advanced customization and styling options in order to visualize the data as per your requirement. And Lucia portfolio can help you build a chart management server, a maritime command and control application, and worldwide our maritime system integrators and end users are using these systems in their headquarters, on small ships for onboard navigation, on frigates, on warships, and even submarine command and control center uses the Lucia portfolio. Here you see the visualization of AIS tracks. So the ships relay their location and via satellite we get the position of the ships. So directly with that, integrating that feed coming from AIS or the NMEA messages, we can visualize dynamic data, we can analyze the ship's position, movement, concentration near a port, do all the custom styling, some geofencing, find the ships, find anomalies, some stops which was not needed, or two vessels stopping and then going further, extending some goods. Filter is based on the time if it's a 4-dimensional data, and additionally add weather data sets on top of it, add multiple other data sets that can be used for navigation, for any use in any functionality which is needed in the maritime domain. A couple of references. So one of our important customers and maritime system integrators, Navantia, you might have heard, they have built this combat management system, and it is being used in frigates, in patrol vessels, in many other maritime vessels. So in the video you can see dynamic line of sights being calculated for different sensors, some fencing, some AIS data, and very easily you can do the terrain analysis and calculations, visibility and invisibility calculation. And for this application there was a very intensive test plan, not only done by the system integrator but also the end users of the Navy, and then the Lucia portfolio was selected to build a high performance combat management system on top of our Hexagon technology. Another example where I cannot show the demo or video for an undisclosed customer, locating the jamming signals or jammer signal location. And one of the questions also were that how do you filter the external interference of some other signal. So like Richard mentioned, Luciad is a API to build applications, and it communicates or integrates all the available sensor you want your Luciad software to visualize, to analyze, or to integrate with. So here on the left hand side, in the top you see a lot of blue lines. So those are the interference coming from the shore. There is a command and control, there is a lot of hardware and sensor there. But what we are visualizing, let me show you image. So our Hexagon team, there were 2 ships with sensor which were sending jamming signals, or let's say they were sending some music was playing to integrate. And on the right hand side in the small vessel, one from our Hexagon autonomy and positioning division, the anti-jamming antenna was placed, and they were sailing around the interference signal with this anti-jamming antenna. And on top of a Luciad desktop application, they were visualizing all the signals, but only filtering or visualizing, styling the signals that indicate the jamming coming from the 2 different sensors. So wide range of sensor integration, interoperability, filtering, discarding the signals which you don't want. So even if there is a long sensors and you want to just see that where the interference coming from, we can visualize it on top of Luciad, but then it depends upon the end user and the use case what to do with that signals, or maybe deploy a hardware so that you can restrict that particular signal from being visualizing in your application. Now we'll demonstrate the tactical cloud, which Vincent and Richard we talked about in our previous presentation, and how it looks like and how it can benefit the defense industry.
So having the ability to obviously gather all this data is very good, as we mentioned a few times, but then how can you quickly and easily catalogue it, disseminate it, make it available to the people that need that data, need that information? So by pulling together parts of Luciad, so we have Luciad Fusion, which is the catalogue and server side, and then we have Luciad RIA, which is our browser-based interface. Usually they're delivered separately to customers or system integrators, and they develop whatever their solution may be. For this solution, we put the 2 together ourselves, as mentioned before, as a one installation process for yourselves. So whether it's on a laptop or a server, doesn't really matter. And then we're using the ability of the server-side solution, Fusion, to actually catalogue data. And that data, as Sarah mentioned, it can be raster data, it can be vector data, it can be maritime data, whatever it may be. We have a myriad of formats and standards that we understand, and we understand them natively. So again, you don't want to spend time translating data, you want to spend time working with that data. And so what we have is a video that won't play. Is a simple interface from this is client side, user side. All they're interested in is what data have I got. So first of all, from the browser, we can connect into NATO friendly forces information, view that because it's a standard. We know that service, we know what it is, and hopefully all forces within NATO are transmitting that or delivering to that service. And then we can obviously quickly and easily view that data. As you can see, it's being delivered live, so it's got the current location of the object moving or the personnel that are moving in whatever terrain, whatever data you wish to have behind it. So that gives you a quick and easy way. You're not worrying about who to connect to, you're just connecting automatically to a service that's prescribed and then viewing the information, the data straight away. So similarly, being able to connect automatically to web services and notification services. So for this demo, we're copying and pasting physical files behind the scenes, but then the solution, the tactical server, is watching those folders, and it's recognising new data. In this case, it was a shapefile that was first brought in of airspaces, and that's then being delivered automatically as a web service. So usually, for your operators, there's a lot of clicking going on as to here's my data, here's the web service I want to make, here's how to populate the service, we're doing that automatically behind the scenes. So whether it's shape files, whether it's vector data, whether it's raster data, whether it's geopackage, we don't care. It's just data to us. And we can then make that available, and as you'll see in the video at the bottom here, it's notifying the user on screen in this case. We also notify the user by email that there's new data available in their area of interest. They don't have to go and look for it, it's already published, it's already available within the globe. And then obviously what you want to do with that data is then quote up to your workflow, whether you want to download it, whether you want to edit on top, whether you want to capture new data. It quite simply doesn't matter. So this part of the video is looking behind the scenes. So this is everything that we've automated. Now, some of you probably use Lucia Fusion anyway. Lucia Fusion, when a user is adding data, is a 1-minute data publishing tool. From flat files on disk to having published web services is all less than a minute. So it's a very easy to use interface. Drag and drop for adding data, and then as mentioned, in this particular solution, we're notifying the users by email or by on screen. Here's some new data, here's the web service. And obviously they could connect to that web service in another client. We're using standard web services, OGC standards, and we can out to message that out. And obviously you can use chat, etc. if you wish to notify colleagues that you're working on a particular data set, so that people aren't duplicating effort. You obviously want the correct operator, correct analyst to work with that data first time.
So another topic, UAV and drones being used more and more nowadays, not only for civil purposes but also for military purposes. We see intrusions of drones in different countries, border area, or drones delivering some packages. So what can you do with Lucia technology for applications that integrate or that are made for UAV and drones? One example here, I would ask Richard to start the video again. So this is an application which is being used by US Forest Department since over 7 or 8 years now. This is a prototype from a couple of years before, which I can show. The operator is sitting inside an aircraft or a helicopter with a large EO camera, and the video is being draped on the terrain in its geospatial application in real time. Because it's a thermal camera, it identifies the spot or the heat or where the fire is. The operator is creating a polygon around the fire, and then from the aircraft itself, from this application, he finds out where is the nearest response team available which can go and extinguish this fire. And in the next versions of these applications, even the deep learning has been integrated, and the polygon creation around the area of fire is done automatically without the manual intervention of the operator, and fully automated system to dispatch a fire extinguishing team in the forest areas of US, and this is being used at a large scale by entire US Forest Department. Coming to more drone and UAV use cases. So whether it's mission planning, whether it's automatic intrusion detection, whether it's draping of the UAV video based on the NATO 4609 STANAG standard with KLV metadata. Here you see a flying object, sensor sending data to the Lucia application with some height information. As soon as it enters the 3D zone, a visual alarm is generated, can be an audio alarm as well. Here you see the cameras, the field of view of cameras, certain drones on a top of a Lucia Lightspeed application. Very easily you can create 3D zones. You can place them where you want to identify the intrusion or do something, some analysis. Once the drone has intruded your low-level airspace or your designated area, and you can develop functionalities to plan your UAV mission or plan mission for multiple UAVs, what area on the ground they will be capturing, which 3D space they need to fly to, or which 3D airspace they should not enter, and where you should plan all this remotely piloted aircraft mission for data simulation, gathering, analysis, and even connect to the real-time video feeds on top of your geospatial application. Here this part of the video shows multiple views a cockpit view looking from the drone, looking at the drone, a 2D view, and on the bottom right you see a terrain elevation profile, which is a non-georeferenced view, but we can also analyze the flight path of the UAV and drones on top of a Luciad application. So all the use cases related to UAV and drones, mission planning, preparation, video capture, overlap capture, planning mission for a swarm of UAV drones, the Lightspeed application or Luciad application is capable of handling that large amount of dynamic data and real-time sensor information and can be used to build all applications in your drone and UAV use cases.
So we've mentioned earlier on about different ways to catalog data, and then about having the ability to get to that data, obviously, and find that data, or be notified about it. But what about analysing it and using it? So deploying the capability to people is where we're pretty primarily at nowadays. We're using our geoprocessing engine underneath the hood. So that is where you can create graphical workflows, which I'll show you in a moment, to process the data. And that data could be, as you can see here, some imagery and some elevation data. But the users can run that processing on demand. So you're not processing data in case somebody looks at it. You're processing data when they want to look at it. So it's always using the latest data with the latest combinations. And so through this particular bit of software, and we're getting better with our software than the videos today. This particular software called MapX, so it's server-based, accessing through the browser, so there's a data catalog, so the users are notified of new data, and then are able to view that data. As you can see, you can display background mapping, raster data, elevation data, all in the browser again. So again, what Daryl and I said about earlier on, viewing the data in the way that the user finds it easiest, finds it best to interpret whatever they're looking for. And then obviously being able to orientate that, so you could make a report out of this at this point, give people the different view aspects, as you saw earlier on with the radar examples. The enhancements here, again, are browser side, they're client side. So we're not changing the source data, we're just applying it to the browser. From this as well, you can then run complicated data workflows. Go back to the right screen. So some of these data workflows can include taking imagery from drones. So Sarah just described about video feeds, but what about still imagery? So from a framing camera, we have the ability to put together a data workflow, which you can sort of see along the bottom here, of processing the data, orientating the images to begin with, processing the data, and then giving outputs of elevation data, of ortho imagery, and again, all within one workflow. So this dialog here, or this view here, sorry, is a non-code interface for creating data workflows. And this particular piece of software is delivered with most of our products now. It's ubiquitous, whether it's desktop, whether it's server, whether it's cloud, etc. So you can use the same data workflows in multiple end scenarios, multiple end users. So in that particular case, we've taken this and orientated it. And then if you're wanting to use some of our AI capabilities for classifying that or detecting change, etc., then in this case, this is one of our classification tools within NS Imagine. So this is a desktop product running the spatial models that I've just mentioned. And here we're saying whether zones are tarmac or swimming pools or green. We're not looking at pixel details because quite often pixels are too detailed. You get too much information, too much noise. So here we're just looking for, is it tarmac, is it grass, is it a swimming pool? And that then assists your analysts for looking in the right areas for new objects or for change or for tarmac, etc. So we're focusing the high value analysts on the bits of data that are relevant, rather than going, here's an image of an urban area, classify it. We're doing some of that for you ahead of the time. So as was mentioned earlier on, we have different ways of classifying this data through deep learning, and whether it's down to objects or down to zones, and these zones can be your areas of interest. Obviously this is a grid in this case, but it's just a grid, it's not set to anything particularly, so it could be a mapping grid, it could be areas of interest, etc., and using that as the base of the classification. So that's a way of getting from drone imagery to classified data through the data workflows.
Another use case I wanted to touch upon is border or perimeter surveillance and security. It's very important for us to safeguard important defense establishments or your borders, where hexagon technology can play a very critical role. And already a lot of the border surveillance and security or perimeter security applications are based on hexagon technology. So on the left hand side you see volumetric lidar based 3D surveillance and security, where not just an intrusion point but the entire 3D space is being portrayed in one of the hexagon softwares. And on the right hand side you see the popular Luciad RIA web based front end, and you see live point cloud streaming and a person walking inside that, and that also point cloud is being, so a web-based command control center which can integrate all your perimeter security sensors and border sensors, and then visualize it with all the industry standard or your custom geospatial data sets, for example here imagery 3D tiles, and as the person which is designated by a sniper icon walks across the hall or across the intrusion area, you also see the line of sight being calculated towards the city on the top of the 3D tiles. So all varieties of use cases and implementations around alarm generation, intrusion, countering those intrusion, or sending dispatching forces to eliminate those intrusion can be done, the scenario can be planned on top of your Luciad-based geospatial application. Another border surveillance prototype, you visualize some 3D models, complex radar coverage with a cone of silence on top of the data, field of view of cameras, line of sight dynamically being calculated from those particular field of view. And then here this part of the application shows if you want to do some cell phone tracking based on the position from telecommunication antennas, or person tracking, what location has lived from one state to another or from one country to another, what was the frequency, do some analysis over a period of time. You want to drape your UAV video flying on the borders in near real time or real time, where you don't have the imagery or you might not have the imagery, but by just flying a drone quickly and integrating the feed with a Luciad application, you quickly get not the videos but also the imagery. Let's say simulation of an intrusion, so the field of view of camera is moving. As soon as a group of person enters the field of view of the camera starts tracking and focusing on and launches the live video feed. And then you can apply further artificial intelligence based algorithms for video analytics, where you can have multiple views of the video but also track the moving objects or count the moving objects. Same scenario here in an airport area. Let's say a tank is intruding, your previous camera identified it's a tank, a 3D model has been assigned, the live video feed as soon as it comes in the camera range starts playing, and with some AI algorithms start detecting the weapons mounted on the tanks. Another application of dispatching security personnel in case of perimeter break from a browser-based Luciad RIA application, visualized using custom and advanced styling with all the blueprint of the house and all the details of the mission and the live CCTV feed on top of of your application screen. So Luciad portfolio can be used in all border security or perimeter security and surveillance requirement, and act as a command and control center for all the defense needs. With this, we conclude this part of this presentation. Thank you so much.